Okay, so in previous session we saw that we are given .c code, we translated it to an object code using -c, then we use -o option as well to generate executable with the name. We also saw how to generate intermediate code. So, we used -e option. Let us try to see, like, if I have to generate all those files in a single shot. Like, if you recall, we talked about this whole process. So, if I say pre-process and pre-process file, this file should be stored somewhere, okay, which may be temporary file. Then compiler takes that file, generate assembly code. We specifically wrote -s in previous session, that is why assembly code was generated. So, what if, like, if I want to generate all files altogether, the pre-processed file, assembly code, object code and executable in single shot, fine. So, earlier we saw -e, when we use the preprocessor output would be shown on the screen. If I use -s, assembly code would be generated, capital S. Then if I write -c, object code would be generated, and if I write -o, small o, which generates an executable with the name provided by the user. Let me achieve this all things in a single command. How can I do that? Fine. So, let us try to first see what are the files that we have. So, let us try to delete my file, my exe, then my program.s, my program.o. Now, we have only these files, my gmtxt, even then my program.c, which is your source file, and then my file. Now, if I have to write this, like, for example, I will write this gcc save temps, then we will write my program name.c. I gave this command, correct. We will write here -m32, so that the file format would be followed with 32-bit. If I write now ls, now see the file generated. With this save temps command, how many files it generated? It took .c code from you as an input command line argument with this save temps my program.c. This M32 helped it to generate the files into object code with 32-bit instruction set. So, this is my program.i, this is a pre-processed file. Now, see the size even. Okay. Then we have my program.s, see the size even 1448, .o 1532. Now, where is executable? Executable is not shown over here, because this save temps will generate by default an executable with the name a.out. So, if I see this ls-ltr, see the recent file, this executable file generated, fine. So, if I write now this, like, ls-ltr my star and a.out. Okay. So, to simplify this, I will write proc, only these files would be the important files for us. So, .c, pre-processed version would be .i, okay. Then assembler generated compiler translated that code to assembly code with .s, my program.s. Then .s file would be taken by assembler, internal assembler used by your system, called as GNU assembler, GAS. So, if you find this, like, you can write this man AS and try to read this whole thing. So, this AS is an assembler internally used, portable GNU assembler, okay, also available in 32-bit and 64-bit versions. So, if what happens is gcc takes .c, preprocessor converts it to .i, .i is taken by compiler, converts to .s, .s is given to an assembly code, or assembler AS or GAS, which generates intel program.o and then a.out. Now, how many files are visible? So, let us write this my program.i. Again it says C source, because it is similar, like the way that we saw output of -e, same thing can be achieved here by writing my program.i. Right. So, this is the same kind of output shown there. Sorry, below your C code would be. Now, see how much big things have been created by it. fine. So, this is exactly containing a pre-processed version. So, it is showing few more things because we created an executable directly. So, if we generate that code before you may say before creating an executable, then it could be different, like the way that we saw the output of GCC -c command. So, we use this one. So, if I write -e command, then it gives me size. So, if I try to count how many lines are there, 735 lines. So, we assumed that only this output is shown, actually no, this output was very big, fine. So, if I write here less, whatever the way that we saw, same thing would be shown over there, fine, the way that we saw that dot I. So, what happened actually, this switch -e is used internally and this file would be saved temporarily. If you do not use save temps, the file would be saved temporarily, .s would be generated, then this .i would be deleted. Even this, if you use -c, it generates .s, converts it to .o, internally deletes that file even. So, that is why we used a switch called save temps. So, this save temps stores all intermediate files generated after each phase of the translation. So, here what we saw was translation phase was take the source code is given to the preprocessor generate preprocessed file, source file is preprocessed now, which is taken as input and given to compiler generates assembly code. Okay. Then this assembly code would be taken by assembler as an input, then assembler converts that file to an object code with the designated file format depending upon what you specified over there. This assembly code would be taken or object code would be taken later and given to the linker, and then it creates executable. Now, let me show you how can we know that what is the linker used over here. So, we have, let us try editing this file. So, if I remove this, if I write menu, if I remove this, okay, and if I write integer function, integer my function. Now, when we write this, we exactly know that this does not contain main. Now, if I try to create an object code, there would not be any error. Let us try to see, like if I write my program dot c dash c, there is no error, but when I try to write this dash m32 dash o my exe, now it showed us error, and here it is showing us this error, LD returned one exit status. This LD in this case is what? This LD in this case is what? A linker internally used. So, if you write man LD, you can find out what is it? It is a GNU linker which takes as an input object code obj file, fine. So, this is how the chain of translation is used internally. So, what we saw was in the whole translation process, source, pre-processing, then compilation, then assembly code generation, after compilation process, then assembler takes that file, generates object code would be given to linker and then executable. Now, it is not necessary that as an input only one file would be taken by the linker, there could be multiple files taken together to create an linkable file format. So, that is the reason why, if you recall, when we saw file command output of a dot file a dot out, it says what? Dynamically linked, and it is a shared object. Every executable that you create, okay, with assumption that it makes use of some internal library function, so that would be created as a shared object which can be used for further usage. So, your task for after this session would be try to find out what exactly this LSB we saw somewhere, this LSB means what is this SYSV, what exactly this build ID explains us, okay. And in next session we will talk about what exactly is meaning of this script. Thank you.